Hopefully.
Okay, good to go.
Uh, let me also pull up chat real quick. But for those that don't know, there's the Phi series of models, right? So this started out way back when Microsoft was trying tiny stories. Tiny stories was like a 1 mil, multiple million parameters. So not even a billion, not even tens of millions parameters models. They just wanted to see, can we make a really small 1 million parameter model like learn text and can it produce any coherent words? Turns out it can. Then they had like textbooks is all you need, where if you train on textbooks, you can do some level of words. Then they had this Phi series. These were really, really small language models. So like up to 1B. Then we went from super small, like million parameter to billion, to now we're at Phi-4, which is a 14 billion parameter model. So they've gotten chunky. I think the sweet spot that they were hitting was kind of that 3B range where no one else was really doing this, right? Like we had Llama, which was 7B, we had Falcon, we had Mistral. These are all 7B models. At the time, Quen wasn't really doing anything tiny, tiny. So these were like the on-device, coherent, somewhat decent models. The history of the five models is that they would do good on benchmarks and then people would say, damn, these models suck. And it turns out that, they were like accused of training on the benchmarks and they were inflating their scores. So 5.3 was the, last one that had a pretty big splash. 5.3 was like, okay, here's a whole section on how we're doing like decontamination of training data. So they basically said, hey, we're serious about this. We're not going to train on benchmarks. Here's how we like filter all our data. Here's how we train our big foundation models. They were kind of decent. Some people use them. Then recently we had Phi-4. This paper came out December 2024. From there, we, as of this week, have got two more papers called Phi-4 Reasoning, Reasoning Mini, and Reasoning Plus. So let's do a quick little refresher on Phi-4, the one that came out, because this is kind of the foundation model that builds on top that the other two build on. So anyone has comments, questions, feel free, pop in wherever. I feel like we covered this in one of the papers, but anyway, we'll go over it again real quick. So, 5.4 now is 14 billion parameter model, and they do basically a bunch of high quality filtering. They use LLMs to filter a bunch of stuff, and then they have a bunch of synthetic data. So, they want to show how like distillation can do pretty good. So they train on high quality data. They have the same architecture as Phi-3, but now they're focused on reasoning benchmark. So this came out like pre-reasoning models, but this is the time when we started to realize, oh shit, reasoning models are pretty reasoning data is pretty high quality, right? So a bunch of the training data here is synthetic data. They have stuff like multi-agent prompting, self-revision workflows, instruction reversal. They have a section on rejection sampling where, you take examples, you have chain of thought, you see what was wrong. They have rejection sampling in there. They do DPO. They start to introduce this concept of mid training here. I think they're the ones that start to like, really push on it. And then, of course, in their new thinking models, they have mid training as like their whole mid training is all you need. But this one was basically synthetic data, SFT, DPO. We can get pretty good models. Mid training is all they need. Here's kind of the benchmarks of how it performed at the time. So, as they always claim, it's kind of 4.0 mini. It's like similar to the 70B models. It's similar to 4.0. But this is a little old. It's kind of out of date now, but still good to know what the overall thing is on. So step zero is this data generation. They have this whole method of seeding data, expanding it out, post-training, stuff like that. And then, performance is on par with even 405B. But they've been known to not have the best like track record of how they actually perform on benchmarks. But from what people say for Phi-4, this is where things started to turn around, especially because they have this whole decontamination set. So like they really kick off the paper with addressing overfitting and data contamination, where one of their original pitfalls is that they have learned to overfit. So They improve their data decontamination process. Basically, they have good ways to take out stuff from data sets. It's what you would expect. They can use LLMs to filter this out. They can not train on variants of data set stuff. They have contamination proof benchmarks that they're doing. Okay, what else have we got here? So, purpose of synthetic data, pretty good, right? It's a form of distillation with SFT, structured gradual learning. What else? Chain of thought data is in there. So synthetic data for pre-training and mid-training. Here's kind of how they do it. So it begins with high quality seeds from multiple domains. Basically, they start seeding data from big domains, right? So they'll do web scrapes. They'll do this seeding filtration process, right? So essentially they'll take big data sets, they'll use an LLM, and they'll start filtering it. So they want to identify what's the highest quality of this data. Then they'll generate synthetic examples and they'll use these examples as more training data. They talk quite a bit about multiple epochs for different sub data sets. But yeah, they created 50 types of synthetic data sets. So web and code-based seed, right? For example, so they have a two-stage filtration process. First, identifying pages with strong educational content, and second, segmenting selected pages into passages, scoring each for its factual and reasoning content. Basically, they're trying to filter out what is good reasoning data here. In this, for question data sets, discard questions where all answered were agreed, where questions are easy or where the answers were kind of inconsistent. So a lot of data filtration, um, delete deduction chains, logical reasoning steps, kind of more efficient. Rewrite and augment data. So seeds are transformed into synthetic data through multi-step prompting workflows. That includes rewriting the most useful content in a passage into exercises, discussions, or structured reasoning. So once you have a lot of text, you subset the best part of it. What are the actual hard questions here? From there, let's rewrite it into exercises. Let's create discussions around it. Let's have structured reasoning to how we got to that example. That's kind of how they do that. Self-revision, instruction reversal for code. So, you have high quality code. Let's reverse it. Let's get the path out of it. Let's get the, generation steps out of it. Um, Filtering web dumps was another one. They have small non-LLM classifiers trained on annotations on how to filter out web dumps. They have subsets of non-filtered and filtered stuff. They over-index on STEM words. They want to just get that high level stuff. They have multimodality into this, multilinguality, sorry. So 176 languages, more extraction, more cleaning. Okay, post-training. Post-training has SFT and DPO, and then we kind of go into their training mix. I think like 5 minutes to cover what they're doing here. But they start off with 4K context length. They extend it out to 16K during mid training. They have a new vocab of 100,000 with unused tokens. Turns out they just left this note in the paper in December. These unused tokens are what the reasoning tokens end up becoming, right? So they add in these think tokens out of the unused tokens, and that's how they're able to do it. Previously, they had had a sliding window attention in Phi-3. Now they do full attention over the 4K context. This model trained from scratch is on 10 trillion tokens. They kind of give you, here's the regular learning rate, weight decay, batch size, all that stuff. But pre-trained from scratch, 10 million tokens, a lot of synthetic tokens. Then after that, they have a mid-training stage where they do this context length extension from 4 to 16K. The interesting thing with all their models, even their reasoning models, like in the reasoning models, they have four stages of training. So one of the things that they noted was like, as we do GRPO, we run into like vanishing gradient problems where, at all lengths we have issues. So at each stages of their fixing these problems, how our performance is doing, how many more points do we get in different benchmarks? Pretty interesting way how they lay these out. It's just like really a lot of learning. Okay, so Phi-3 was two stages. Phase one was largely filtered web text. Phase two was basically, small subset of reasoning tokens, basically like the high quality code and math. In this case, they show that web data sets had small benefits on reasoning heavy benchmarks. Models trained with only synthetic data underperformed on knowledge heavy benchmarks as well. So, you know, we need to fix these things. TLDR, here's their data pre-training mixture, where we search over different allocations of tokens coming from various sources, mainly synthetic, web rewrites, web filtration, divided into reasoning and knowledge heavy portions, targeted acquisitions, and organic data. So math, books, stuff like that, forums, code data. Then there's a correlation between 7B and 14B models. Basically, they noticed that the scaling was pretty consistent. So they did a lot of their data pre-training mixtures on a 7B model, and then they transferred that understanding over to the 14B. Um, let's go a little bit faster. Here's their subset of the final training of their 10B tokens in the pre-training stage, or I don't know if it's 10B because they're still post-training, So like, let's see, probably 95% of the training is here in pre-training. The interesting thing here is, they have a lot of epochs for different data. So like synthetic data, even though there's only 290 billion tokens, it's actually 40% of the total pre-training because they go over it with 14 epochs basically. But yeah, so to keep everything general, 30% of the training tokens are for web and web rewrites, namely 1.3 trillion tokens of just web scraping. Web rewrites are 290 billion tokens, but we do multiple epochs on that. Then the remaining tokens are largely from synthetic data, which is 40% of that. 20% of this is pure code, and then acquired sources are, like the stuff that like the textbooks and things like that. Um, that's most of the pre-training. Then they have their mid-training where they extend context length. Here is, where they are high quality non-synthetic data sets separate. So they filter out in these pre-training sets which one of these samples have long context, right? So in their pre-training, what is over 8,000 tokens? What is 16,000? Then they upweight subsets that are long, right? Then they do synthetic data sets to have more than 4K. Um, data set of this long context extension is 30% newly curated and 70% of previous stuff from the original pre-training. Then, here's how it performs on different long context evals. So recall, RAG, re-ranking, summarization. Here's how the models actually perform. And they show pretty good benchmarks on this, and they kind of explain for people that don't understand what are long context benchmarks. Here's kind of the ones that exist, right? So recall, this is basically retrieving corresponding value from randomly generated long files. RAG, answering questions with QA. This is a subset of these data sets. Re-ranking is, you're given 10 documents and a query. You want to re-rank them. QA is question answer over long document. Oh, my thing has froze. Okay, never mind. It just decided to break my PDF reader a little bit. That's cool. Okay, after that, they have post-training, they do DPO. This is basically let's make it a chat tune model instead of a base model. Interesting thing to note in the paper this week in the thinking model, one of the approaches that they tried was instead of using the actual Phi-4 model, what if we take the base model and not the instruction tune model? And what if we do all of our thinking from there? And they're like, actually, it does pretty well, but not good enough. So, and spoiler, they end up just using their instruction tune model. But very open how they do this. So, they use chat ML, user assistant, they have DPO, they have SFT, they have multilingual data. This is pretty interesting. They only need 8 billion tokens out of their 10 trillion during their SFT and post training. So, DPO is, alignment. SFT is for following that completion. I think that's basically enough for high level what's going on in Phi-4. Performances are as you'd expect, it's a 14B. There aren't many 14Bs anymore. They have sections on red teaming weakness. They have a lot of like just open research. But yeah, that's kind of where they sit. They have 14B models. They do a lot of filtration. They do pre-training. They have this set of mid training. They have SFT, they have DPO. It performs pretty good. It's on par with what you'd expect, you know. It came out after Quen 2.5 B14 instruct, so it's slightly better. Better than Phi-3, of course. When you look at stuff like 4.0 mini or 4.0, you know, in some cases it's better on math and GPQA. They say it's better. Human eval, so coding stuff like this, slightly worse. Simple QA. One thing that they note, you know, like in some of the problems with these models is that when you have factual like recollection, they do note that small models just struggle with this, right? Model small, model can't recognize a bunch of facts, so on QA, it's not the best. Big model will always do better. Um, but yeah, that's kind of what Phi-4 is at a high level. It's cool, you know, it's like not better than Llama 3.370B, but in some areas it is where, you know, they tried to get this reasoning data through SFT and slight DPO with just filtration and a lot of synthetic data. But okay, I will pause here since that's mostly Phi-4. From there, we'll go on to the two reasoning data sets, but any questions, any thoughts, questions, comments, concerns? Has anyone used it? Probably not. They get some use now. They're like actually hosted by most people. They're on the they're there through Azure and stuff, of course, but some people have started using them, you know. But anyway, any questions, any thoughts? Okay, chat. Someone has said something. It's interesting to me Phi reasoning distill from O3 and Phi-4 mini distill from DeepSeek. Why they use completely different SFT curated data sets, also kind of different SFT strategy. Yeah, it's an interesting note that they make. So the papers that they released this week, let me actually change my screen share real quick. So this came out in December. They have two models that they released, kind of three actually. So Phi-4 Mini reasoning. This builds on Phi-4 Mini, so it's actually a 3 point something B model. Let me check real quick. This is roughly a 3B model, and they show that, you know, there's a whole different set to getting 3.8B. There's a whole different formula to getting a small model to do reasoning than there is to getting a large model to do reasoning. So one of the interesting notes that someone in chat pointed out is that when they do Phi-4 mini reasoning, they do their distillation from DeepSeek, but when they do 5.4 large, the one on the 14B and the plus, they do it from O1. Sorry, from O3 mini, which is interesting. Who knows why? But there's so many little gems in this 5.4 mini reasoning paper. Like, for example, um, they cite a bunch of recent sources of getting small models to do reasoning. Basically, they start with DeepSeek R1, right? So DeepSeek R1 had distills. They had Quen and Llama distills, and they show how they can do better. After that, there was a bunch of stuff like stuff from OpenHands, stuff from S1, and they make little notes here, right? So like there's other things like there's Open Thinker, Bespoke Labs, but one thing that they noticed was like if they take the S1 and Limo data sets, S1 was basically, you know, 1,000 samples of reasoning data trained into Quen 32B, I believe, had a really good reasoning model, right? So 1,000 samples is all you need. They show that if they do this SFT on 1,000 samples of their mini 3.8B model, it actually performs worse. So even though it performed well for S1 is where they did it at 32B. They took a base instruct model. They did 1,000 reasoning, high quality reasoning samples. They got reasoning. It worked very well. Benchmarks shot up like crazy. S1 paper was pretty cool, but pretty basic. They show that if we do the exact same thing on Phi-4 mini, so we take a 3.8B model that's competent, good, instruction tuned, we do 1,000 samples of SFT on really good reasoning data set, our scores actually go down a lot. So base model had a score of 10, 78, 37. It shot down to 3, 47, 26. So TLDR is, you know, that actually doesn't work. And I don't remember, I was like trying to quote something in this, but they keep saying like, we need to explore a better recipe for how to do reasoning tiny models. This paper is basically a blueprint for that. But, you know, it is based on DeepSeek. I would assume the reason that they do DeepSeek to answer the question exactly is because they're specifically comparing their model to Llama 3 8B, the distill, and the Quen distill. So they're training on both, they're comparing to both distills, and you know, why not use DeepSeek? But anyway, before we move on to that and then the large one, any questions on regular Phi-4? Okay, we move on. Someone asked about training on synthetic data risk the effect of hallucinations. So if you look deeper in their like synthetic data processing, they have heavy filtration. So for some stuff that's questionable, for some stuff that has like good chain of thought but not the right final output, they deal with that. But basically, you know, they have verifiable math output, they have verifiable code. They basically have really good pipelines to test whether outputs are correct or not. And then this is a lot more shown in the Phi-3 paper as well. Is there any justification on why they did so many epochs in synthetic data or any rationale behind that? So in Phi-4, yeah, basically they're just saying that all their synthetic data is just higher quality, right? So they start here. Oh, sorry, it's a reasoning paper. Basically, they start with the web scrape is decent. We can filter it down and then expand it, and it's all better quality data. And then in Phi-3, they show some of this too. But the number of epochs is kind of interesting. Specifically, like when they show in context length extension, something they talk about in a lot of these, and they also do actually mention this in later, like towards the end. I just don't think it's worth covering since these are more so reasoning benchmarks. Some of the interesting things that they note is they do like this method of packing and unpacking prompts. Um, they also show how they'll repeat long context examples that were done in pre-training. So even their method of multiple epochs is like not necessarily reflecting the exact number of samples. But although I'm sure it's very minute, um, you know, in the, where's this chart? In this pre-training, like for example, the web data has 1.3 trillion tokens and is 1.2 epochs. In the mid training, where they do context length extension, they once again use the previous samples that had more than 8K context. So they do create synthetic, but they also reuse. So, like, you know, this is a little skewed, but I don't know. They just show that synthetic data is good. The other nice thing about these papers is that they basically cite everything. Um, a lot of citations. But what they show here is like a bunch of synthetic data, model go good. Um, as you would expect, the reasoning models kind of follow that same trajectory, right? A lot of synthetic data, model can reason, model get good. But let's start with the mini reasoning model. So um, Phi-4 mini reasoning. This is the 3.8B reasoning model. Okay, so improving small language model reasoning remains challenging due to their limited model capability. Also, are we seeing my entire screen? Okay, we are making sure we're on the right paper. Um, so they kind of bring up R1 did distillation, right? So distillation from LLM generated synthetic data can improve reasoning, and they show that even doing SFT works. So this paper, this work is trying to get a systematic training recipe for small language models. They have 4 steps. Step 1 is large scale mid training on diverse distilled chain of thought data. Step 2 is SFT on high quality long chain of thought. Step 3 is roll out DPO to leverage a carefully curated preference data set. Step 4 is RL with verifiable reward. So 4 steps. Here's how we do reasoning on tiny model. And at the end, they show that, you know, their compact 3.8B reasoner can outperform Distill Reasoning Quen 7B and Distill Reasoning Llama 8B by, you know, a little bit on math. Um, they're starting to do even more and not overfitting here. So they have sections on like calendar planning, and they're like, this is something we didn't explicitly train on at all. We filtered out data sets in our training, but our models start to generalize. Like they do really good on this task, and this is something that wasn't trained on at all. Basically, they validate a carefully designed training recipe with large scale, high quality chain of thought data is effective to unlock strong reasoning capabilities, even in reasoning constrained small models. I don't know what their like team is up to with chart colors, but here they go all pink and purple. So here's, you know, AIME 24, Math 500, GPQA Diamond. Um, The original Phi-4 is this shade of purple. The R1 distills, you can see how they're actually pretty good. So Llama and Quen were pretty good, but hey, their tiny model at half the parameters can do even better. They're winning. I thought this was interesting. Equal contribution for everyone except the first and last two authors. Screw the others. They're just listed first, but not equal contribution. Those charts are pink. These charts are colorful and different. But okay, back to this. I feel like me sitting here and reading through charts is useless. But oh no, my reader is broken. Okay, if interested, here's kind of how they perform. Small models. It's interesting how they put 4.0 mini kind of under the small model section instead of large models. In 4.0 here, we don't really know how big 4.0 mini is, but it's there nonetheless. Um, oh, wrong chart. My bad. Let me go back to this. Okay. Sorry, wrong chart. Okay. Basically they start off with their intro. They're like, chain of thought is a way to do reasoning steps. It's cool. They say that small language models struggle with chain of thought. I thought that's kind of interesting. Um, Enhancing reasoning capabilities is easier for for large language models due to extensive capability. It remains challenging for small reasoning models. Um, DeepSeek R1 shows that non-logit level distillation, basically just SFT with synthetic data, makes good reasoning performance. Then they cite all the other stuff. Then they show the other people. So, um, Bespoke Studio, Bespoke Labs 7B, Open Thinker 7B, they show that um, they can do this with SFT. Some people suggest GRPO, Deepscaler does. S1 and LIMO um, show that, small samples, even 1,000 samples can do good reasoning. Okay, rather than focusing on isolated techniques, we explore training paradigms specifically tailored for small language models. So, um, they have two stages of distillation, followed by rollout-based learning that reuses wrong LLM generated samples and concludes with RL with verifiable reward. Initially, we employ a distillation as mid-training mechanism to embed foundation models with reasoning capabilities. Then they apply distillation again in fine-tuning to further improve generalization. Then there's LLM rollout sampling for distillation. Incorrect outputs are typically discarded. However, they want to still use them. So they have this way of doing this. They take a sort of RL approach where they have it optimize long. So if the answer is incorrect, it should still think a lot for incorrect examples. And then they want conciseness on correct examples and stuff. They talk about this later. Then they fine tune it with RL for final correctness. Um, Outcomes, Phi-4 reasoning. Okay, more background. Optimal distillation strategy for small models still unexplored. They keep repeating this. Um, you know, Data diversity. So they showed that, data diversity and quality is very important. Applying isolated techniques degrades performance. So they tried S1 on Phi-4 Mini, went down, which I thought is pretty crazy. Um, their goal is to once again comprehensive, efficient training recipe for small language models. So non-reasoning models require a mid-training stage to absorb a large volume of reasoning trajectories before additional techniques are applied. So once again, if small, we need mid-training. They love this concept of mid-training. So quick questions to ask is how much mid-training do they need? And then what do we do after mid-training, like careful distillation, preference learning, RL? What should we do next? Once again, systematically address these questions and propose a recipe for building small reasoning models. Mid-training is basically and after pre-training and before post-training. It's mid-training. Um, it's like, you have SFT for post-training, but before you do that, when you have base model, is there something that we can do to do this sort of reasoning? Or before this specific RL, DPO, before that last step of most high quality stuff, basically, if you take an instruction model like Phi-4 Mini and you just do direct 1,000 samples of high quality data, like you're cooked. You're not getting reasoning. The models, the small models cannot pick that up in time. So they're saying mid training is where, you need this stage of let's do some chain of thought, extended synthetic reasoning data. Let's roll out reasoning tracing steps. Let's have thinking steps. Let's do a lot of those. Then we go once again to our core examples. Um, that's kind of what that's kind of what it is. And yeah, it's like basically train on chain of thought before your RL. Okay, multi-stage continual training for reasoning. So multi-stage continual training is good. First, we do that. We train curated chain of thought reasoning data set. Then we run RL with verifiable rewards. Okay, so can distillation be used as mid-training? Yes, we want to use distillation. So we train base models with next token prediction on extensive corpus of synthetic chain of thought data. Chain of thought are generated from DeepSeek R1. We apply rejection sampling, only get the correct answer. They talk about this later in section 4. We pair questions with correct chain of thought, with corresponding correct chain of thought answers. Train a base model using standard causal language modeling, objective. They have a packing mode. So basically, what they're doing here is not just SFT on reasoning. They're packing in multiple examples into one training set, right? So multiple examples are packed into the same input sequence to increase token efficiency. So we're not specifically trying to learn what is input output. We're not doing SFT to just do reasoning step answer. We're doing multiple examples. So like they're packing in a bunch of them. So like you could have 7 examples of input, chain of thought, output, input, chain of thought, output. And we're just trying to learn and mid training, here's how we do chain of thought. It's not just good answer generation. This is like an effective way to use mid training, to effective way to allow mid training to iteratively use as much chain of thought data as possible until the model starts to perform well on a validation set. Then we have distillation for SFT. Basically, after it started to learn how to do this chain of thought, we do fine tuning or just continual training in a non-packing way. And then that's where you teach the model where to stop generating text. Okay, after that, rollout preference learning. This is where, the previous 2 stages is trained only on accepted generation. So they've done filtration, they've taken out all incorrect examples. They're only doing positive chain of thought. Here's question, here's chain of thought, here's answer, pack it, unpack it. You now know how to think, you now know where to stop. But now they want to use rejected rollouts to enhance performance. Basically, this is how they like ensure that you have diversity, you have enough thinking, you have, conciseness. So basically, incorrect responses with minor nuances are compared to their correct answers, and they provide positive, effective candidates for constructing informative preference pairs. So you can do preferences of, here's the right thinking approach, but the answer was wrong. And then here's the correct way to do it. This preference data set is constructed by using correct answers as preferred rollouts and incorrect as dispreferred rollouts. So now, we have DPO. We're going to do DPO, and we have here's chain of thought with correct answer. Here's chain of thought where you kind of messed up a little bit. Let's do that. Then we have RL with verifiable reward. So now we've done some alignment with DPO. We want it to, we want to have preference towards these pair of examples, but now we want RL on the distilled and preference train model. So in the following, we describe RL algorithms that we've implemented. So PPO. PPO is a clip surrogate objective to limit the policy update so it stays close to previous policy. Clipping is doing this, da 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 da. It has stabilization. Basically, this is where they want it to okay, let's see. We have PPO and GRPO, GRPO. We love our GRPO. Um, Comparing rewards in a batch with multiple responses. So for each question, we sample a set of responses under the old policy, compute their rewards, average out what we want. There's a verifiable reward for the right one. Standard RL stuff at these days. What else? High variance in response length. So our pilot study applying GRPO to train base model, we observed three issues that affected stability and effectiveness of model training. High variance in response length. So although the base model after mid-training is already able to generate chain of thought responses, we observe substantial variability in response lengths within the same GRPO sampling group. So when you generate multiple outputs for the same example, there's a lot of variability in how long that is. So for some stuff, positively reward responses range from 12,000 to 20,000 tokens, which is, pretty large. Optimizing the model for standard GRPO, um, it led to instability, right? Okay, vanishing gradient. This is what you would expect. So as they did a bunch of these, as they had so much diversity, so many different lengths, you kind of had identical rewards. So vanishing gradient problem, zero variance in the returns. Um, the model is sensitive to intra-group length discrepancies, requiring extended GRPO batch size to 128. So more batches in GRPO while it worked. Um, we hypothesized that these issues become more prominent for small language models where RL stability is likely to be more fragile compared to large models. Okay, moving on quick since we're short on time. What else? Synthetic chain of thought data generation. So we construct large-scale reasoning data set composed of LLM generated synthetic reasoning capable trajectories. They use a bunch of pre-made data sets. So basically all these are open data sets and their sizes and whether they have reasoning or not. Um, for data sets that already had reasoning traces, we directly use their annotation. So basically, Bespoke Labs, Open R1 Math from Hugging Face, and Open Thoughts from Open Thoughts. That's roughly what is that, like 350,000 samples. It has reasoning annotations. They use that. For the other ones, so all these 6 or 7 different data sets, we retain only, for data sets lacking such trajectories, we retain only math questions and generate new chain of thought answers using R1, the big R1, 671B. For each question, we sample approximately 8 rollouts, and in total, we collect 10 million rollouts across 1.6 million samples. So they use all these. For the other ones, they use big R1. They only use math. They get 8 rollouts per. Now they have 10 million samples. All the previous training steps, so the mid training and stuff, that's used with this data set. This is not like a new training stage. This is just explaining the previous steps above. Okay. This is kind of interesting as well. For math questions that are verifiable, we first apply math verification tools to address correctness. Some auto verification fails for complex solutions. And then it says we additionally employ 4.0 mini to re-verify rollouts initially flagged as incorrect. I thought this was interesting. Like, we're in like mid 2025. We have O3, we have O1, we have 2.5 Flash, we have Sonnet, we have all these big models, but let's verify our math with 4.0 mini. Like, let's think about that for a second. We have benchmarks, we have tables, we have everything, but for verifying if our math was flagged as incorrect properly, let's use 4.0 mini. Why do we use 4.0 mini? That's for Microsoft for them to not tell us. Could they have used a bigger model? I think so. But anyway, um, they do that. Okay, experiments, evaluations. We evaluate our model on 3 mathematical. Uh, Possibly they're obsessed with token cost. 4.0 mini validation. I think 4.0 mini validation is just, it's mini model. Let's compare it to mini. Um, 4.0 mini was compared to Phi-4, the 14B model. And based on estimates, people say active parameters of 4.0 mini are small. So that's fair. For token costs, I mean, I don't know. These are not cheap models to train. This is a 14B model trained on 10 trillion tokens. That's a lot of compute. That's in the millions of dollars of compute. One thing I highlighted here that I might have skipped over was how cheap training Phi-4 mini reasoning was. Um, like I'm not gonna say it's like DeepSeek R1 cost $5 million, but there's obviously a lot of filtration, a lot of time, a lot of synthetic data generation, a lot of inference that goes into this. But they trained this on, I believe, 32 H100s for like 2.5 days. So like maybe 64 H100s, but very few nodes were used. So like this is something that someone could do themselves if they really wanted. If someone can actually pull up the Phi-4 mini reasoning model on Hugging Face, it explains the GPUs used to link it. Just share it in chat and we'll go over it real quick. But that was something I wanted to note. Um, Training this thing, the reasoning model, outside of generating that data, which honestly, even in and of itself, they just used a lot of DeepSeek R1 and they used open data sets. Like this thing didn't cost that much to train. Two nodes of H100s for 2.5 days. Like that's on the scale of tens to hundreds of thousands of dollars. So not that crazy. But yeah, what else? To show their results, once again, they're very cautious of overfitting on benchmarks. They do 3 runs and they report the averages, and they have a whole section on how they need to redo on how we need to better evaluate reasoning models. They have a section on like reasoning models versus non-reasoning, where these evals sit, baselines and stuff. But yeah, they kind of show that, the thing's pretty good. Training strategies, this is very straightforward, right? So what do they do? In the distillation stages, what's the batch size, learning rate, how many epochs, warm-up ratio, sequence length, packing, not packing, this is all just, if you really care about that, go ahead and read it. We're running short on time, so I will not read it for us. On scores, here's kind of where they sit. So once again, like they show all of their stages, right? So basic 5-4 mini sucked at these math and reasoning benchmarks. O1 mini good. Distills pretty good. The other people, not so good. Base llama, not good. Adding distillation mid-training, ooh, lot of bonuses, lot of pretty good stuff. Adding distillation fine-tuning after, even better. Adding rollout DPO, even better. RL Gripple, wow, we're good. It beats everything. Actually, it doesn't beat everything, but pretty good. Beats R1 Distill Quinn 7B and R1 Distill Llama 8B, which, when DeepSeek came out, a lot of people for local inference were using DistilQuen 7B. Tyler has linked the Hugging Face thing. Let's check it out real quick. Context length. What model is this? 5-4 mini reasoning. Okay. Da, da, da. Model quality H100 GPU times 128 H100s for 2 days of training. So, not that much. Assuming $2 per hour for H100, 128 times 48 hours is $12,000. Math checks out, but math doesn't really check out. You can't assume $2 per H100 hour because, you're doing this on actual nodes of training. But yeah, per hour on H100, you can say 12K. Now that you're doing it on node level, maybe double it up, maybe triple it up. But point being, tens of thousands of dollars for this, hundreds of billions of tokens, not trillions of tokens. And this is stuff that like low-key could have been done earlier. But yeah, they show it out stage by stage. Thank you, Tyler, for link and um, quick math. They show out stage by stage performance, ablations, fun charts, safety. We need safety. Hours stay consistent, others go down. What else? Conclusion. Okay, they love their line. Small models, when trained with deliberate data selection and training strategies, can match or even exceed capabilities of larger models. They want to show this work as a blueprint for developing efficient, high-performing models under resource constraints. Now, one of the very interesting things is, some of the other work that's referenced here, like the distillation models, Distillation with SFT is cool. DeepSeek showed it really worked, right? Let me see if this chart actually compares to base llama. I believe they have it in there at the bottom. So basically for, let's change color real quick. For regular llama 3.2, oh, they did 3B. God damn, never mind. I was trying to compare llama 8B to 8B. But okay, let's just say for Phi-4, which is better than 8B, on reasoning data sets, we did really, really bad. Now, what DeepSeek showed is with basic SFT on reasoning data, you can get pretty good performance. What they show is if you have a well thought out process to do this specifically for small models, you can do even better than what people were very amazed by in the past. So, um, this thought out way to do this is really good. Um, what else? What else? So they basically have this as a blueprint for small model thinking, RL. What was interesting was just, yeah, stuff doesn't directly transfer over, you know? So S1, someone correct me if I'm wrong, I think was done on Quen 32B, right? Or one of the large ones where, you take 1,000 samples, you have small model, and now you have really good reasoning. They tried that exact recipe with their small model. They took Phi-4 Mini, they did S1 training, and not only did it not improve as much, it actually got worse. So, this stuff doesn't transfer over at face value. For regular foundation model stuff, it does. Like in the regular 5.4.14b, um, they did a lot of their experiments on a 7B, and then they did a lot of their pre-training data experiments on a 7B, and then they transferred over to a 14B for actual train run. Where's this? It's somewhere in here. Yeah, right here, right here. So we observe a high rank correlation between the performance of 7B and 14B models on different data mixtures. Given large enough distance between the two data mixtures, this allocated us to conduct experiments on 7B scale and transfer findings to Phi-4, which is 14B. The key difference between 32B one and this one is mid training. No, so this one is a 14B, which also had mid training. This is basically a mixture of bunch of stuff, the small reasoning. Um, there's a whole bunch of sets of this, but here, yeah, basically they have a whole bunch of let's learn chain of thought, packed, unpacked to know where to stop, then let's do RL. That's a better approach for mini reasoning model. We have questions and discussions, but this is not the only paper that dropped. I, in fact, was bamboozled an hour ago when I decided to read these. Turns out there's like low key 2.5 papers. So we needed to know Phi-4 base to see what they did. Then there's Phi-4 mini reasoning, which is their 3.8B. Then there's also just Phi-4 reasoning. Phi-4 reasoning is not one model, it's actually two models. 5-4 reasoning is where they take the 14B model, they do they make a reasoning model using O3 mini traces. And they have another one. They have Phi-4 reasoning plus, where they basically do the same thing as before, but now they add RL specifically. And now they're comparing it to the 70B distills. And guess what? It does well. It outperforms the 70Bs. So same benchmarks, reasoning benchmarks. We show that the benefit of careful data curation and SFT extends to reasoning models. This can be further amplified with RL. So similar to how there's like O3 mini, low, high, O1 pro, all that stuff, they can also do this. So they have 5-4 reasoning and 5-4 reasoning plus. Could this paper have basically just launched 5-4 reasoning plus and called it 5-4 reasoning? Yes, they didn't have to do two. This is very similar to how in the reasoning mini paper they have, oh shit, this is the big one. One sec. In this reasoning mini paper, in the mini reasoning paper, they show every stage of training and how it performed, right? Like they could have also had Phi-4 mini reasoning and then Phi-4 mini reasoning plus and do their whole recipe. Like it's starting to do better as it is. But in this one, I guess the point they're trying to make is that an additional RL stage takes you from Phi-4 reasoning to Phi-4 reasoning plus. Um, Yeah, TLDR is they're getting O1 mini O3 level performance, beating R170Bs. Yeah, okay. I'm gonna try to go through this in 3 minutes. Sorry on bad use of time. Um, how they do this. So 14B model, it's Phi-4. Uh, they have 14B model, supervised fine-tuned. So they do SFT. Then they have Reasoning Plus, which has a further round of RL. 1.4 million prompts of high quality answers containing long reasoning traces generated using O3 Mini. Prompts are filtered to cover a range of difficulty. They want it to be stuff that the regular model can't answer. So if Phi-4, is there any traction on these? Yeah, five models have decent traction. The reasoning one just came out. I don't know about traction on this. Um, so they basically want to filter out stuff that the regular Phi model can solve. They only want to do stuff that it can't solve. My highlighting got weird. So the data set used in SFT includes STEM topics, coding, safety focused tasks. The Reasoning Plus model is trained using RL on a small set of 6,000 high quality math focused problems with verifiable solutions. Kind of interesting, right? They get so much performance gain from just 6,000 samples of RL. They talk into how RL is like, it has high variance, but it also has high impact if done correctly. But then it's just math, so live code bench went down a little bit. Interesting thing to note. Okay, basically it's data like the whole training pipeline. It matches what they've done in previous Phi models, Orca models. Uh, they once again want to show that good data curation, synthetic data, small models to be good. Small model performs better than O1 Mini 70B models. They also outperform Claude's 3.7, 2 thinking on all tasks except GPQA and calendar planning. Performance on this, okay, performance is cool. This was kind of an interesting one. Both of them present improvements over the base models, including math and specific, notably improvement of 50 percentage points here. Surprisingly, these models also improved by 30 to 60 percentage points on algorithmic and planning problems like calendar planning, which demonstrate increased generalizability of reasoning skills to domains that we did not target directly during SFT or RL. So, on stuff they didn't target and didn't train, this shit still generalizes. Very cool, very cool. Improvement on general benchmarks. Of course, it improves. Here's numbers of how. Thinking effort versus accuracy trade-off. This was interesting. So, the reasoning plus model that slapped some RL that does better, it takes approximately 1.5 times more tokens than the other one. This difference is less pronounced on other reasoning domains. So uses this on average. So some domains like coding, planning, spatial tasks, these are all avenues to improve RL. Okay, keep going through quick. Phi-4 demonstrates reasoning responses. They show some examples that the reasoning one did that the other one couldn't. So this is a wordplay riddle. This is a question, I have coin tosses. What's the chance I see exactly 1.2 heads? Phi-4 would give you, an actual math calculation. The reasoning model is like you can't get exactly zero point 0.2, so probability is zero. Pretty cool, pretty cool. More stuff, planning, games, crazy. It can do games. Data stuff. Seed database, we specifically target seeds situated at the edge of Phi-4's current ability. Additionally, to maximize the focus of reasoning skills in dataset, we prioritize prompts that demand complex, multi-step reasoning as opposed to those testing factual knowledge. So they want reasoning stuff, they want teachable things, synthetic seed. Sorry, I'm going quick. We're at like 1 minute left. So I'm gonna go through this quick. Phi-4 reasoning, basically SFT on Phi-4 with specific tokens. They have reasoning tokens. They use two of those empty tokens that they have. They have think and think tags that they add in. Increased token length, so they extend to 32K, synthetically generate examples of long chain of thought over this. Our SFT dataset is 1.4 million reason prompt response pairs. Um, totaling 8.3 billion unique token samples. So this many extended out over these domains. Here's training, here's SFT steps, here's improvement. During exploration stage, we studied effects of various design choices. Here's that, role of SFT seed, hyperparameters, role of system message. Of course, system message is useful. So um, basically, to promote chain of thought, they tell the thing, you're a system, you're a thinking model, have your thinking in think tags. Partially removing or replacing system messages was cool, but it didn't work. Here's the exact thing. Your Phi, a large language model by Microsoft. Your role is an assistant involves thoroughly exploring questions. Da 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 da. Please structure responses in two sections: thought, solution using the preferred method. Think, thought section, and think. Then solution section. In thought, detail your reasoning steps. Each step should include analysis, summarize, brainstorm, da da da. Solution section should be logical, accurate, concise. Um, Now try it with the following guidelines. So that's our system message. It helped optimization base model. So they considered using the base model before SFT, like we talked about. So the 14B before that SFT, um, both of them worked pretty well, but the one with SFT and instruction tuning did slightly better, so they use it. Um, we attribute this to addition of safety focused post training. Wow, safety is all you need. Um, Scaling final model was trained on 16B tokens in this. Okay, real quick, the plus. So they did 6,000 samples of RL. We applied outcome-based RL to enhance reasoning capabilities. They use Gripple. RL is math reasoning. 72,000 math problems, subset to 64 seeds of that. We do small set of 6,400 problems, seed, no coding. Reward function, they want it to, or is it basically incentivize correctness, penalize undesirable behavior such as repetition and excessive length, and encourage proper response formatting. We encourage the model to generate concise outputs when it's correct, provoke thinking to think more when it's incorrect. Here's how they do that with GERPO, repetition penalty, training details. This was the one that was batch size of 64 over 32 H100. So sorry, the mini that we talked about was 128 H100s, but this reasoning plus was only 32 H100s, 64 batches for that much. It's like a couple hundred hours. They also do context length extension here. But I think that's enough. I don't want to go too long over. They have evals. Of course, they have evals, but I want to, even though we're over time, I want to give it 2 minutes for questions. They have a whole main findings, takeaways, stuff like that. I'm gonna go over chat real quick, but if anyone wants to pop in, share, please, interrupt me now. Yeah, so they call this SFT instead of DeepSeek's use of distill. So distill has like a term of distillation loss, right? Where you kind of compare output logics and you kind of force what did big model say? Let's do actual distillation. They do note how this is basically just SFT on big model outputs. That's the beginning. What's the difference between Phi-4 reasoning and reasoning mini? Oh, Phi-4 reasoning is on their big 14B model. So Phi-4 14B gets trained to do reasoning. It's on par with O1 mini, O1, and 70B distills. The reasoning mini model is done on a 3B. So reasoning mini, they do post training on a 3.8B, and they show that they can match distill 7Bs, and they show that, if you take what distillation was done to big models and you directly apply it to a small model, it doesn't work. So they try the S1 data set on a small model, it does worse, but they have a blueprint for how to do this for small models. Is there anything interesting in the mini ablations section? Maybe which part they deem most important for small models following their narrative is mid-training, or do they imply the combination is the key? Let's see. Let's see. Our distillation pipeline serves an effective approach to measure reasoning, blah, 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 pass IK. I don't think there's much that's reasoning here. Much that's super important. Basically, they just have like a you need to do some mid training. They pose some open questions. Um, yeah, cool. Okay, thank you everyone. Sorry for last minute paper change. I low-key read this like an hour and a half ago, but hopefully it was useful. I'm sure some of this is wrong, but yeah. Next week we should have Professor Tom who does by hand illustrations, talk about the differences in Llama 1, 2, 3, and 4 architecture. I'll share more in Discord. He was gonna just do Llama 4, but we pushed it a week so he has time to prep to do a better comparison between, what's actually changing between the series. So that should be next. We always need volunteers, so if anyone wants to volunteer a paper, let us know and we'll slot you in. So Flo says, I can't wait till GPT 5.4 drops, and I can't tell if people are saying 5.4, like GPT 5.4 or 5.4. People will be saying GPT 5.4 because no one talks about the Phi models. These are cool, but really, really not many people talk about them. Not many people use them, but it's always nice to have, it's open research. They do a lot of work, but yeah, nobody really talks about these. The only people that talk about them are people that kind of shit on them for um, training on benchmarks. If I'm not mistaken, they made one of these multimodal and Phi-4 or Phi-3 with audio had the best transcription word error rate. Someone fact check me on this, but I'll follow up somewhere. I'm pretty sure the multilingual version of this had the best word error rate out of any model. Now, that's not saying a lot because speech and transcription models are small, like low latency, efficient, optimized. This is a fat model, but yeah, multimodal large models get good, What can you say? Okay, I feel like that's enough. Thanks, guys. Okay, I would end meeting, but Swix is host, so he will end meeting.